Hello guys, welcome back with another video. Today we're gonna talk about the titration of the amino acids. Last video we talked about the acid-base chemistry of the amino acids. Now the titration of the amino acids. Acid-base preparation. Amino acids are great candidates for the titrations. We assume that the titration of each proton occurs at distinct setup. And we have three types of setups: the monoprotic, diprotic, and triprotic. Is donating only one hydrogen, or proton, atom, pair, one molecule, to an aqueous solution. Give an example of this, like the titration curve. Basically, this is the base, and here's the acid. We do have here the equivalence points. It's always has a pH of 7. And the buffering region will be at this on the acid side. Buffering region. The second type is the diprotic. Donating only two hydrogen or proton atoms. Example of this, we're gonna have two equivalence point at this time, because we're gonna have this curve. So the equivalence point is gonna be right here, moving from the acid to the base, and here continue moving to the to become a basic. And this is gonna be the base acid. So now in that curve, in the monoprotic, we're gonna have only like 1 pKa. We're gonna have only 1 pKa. Here we're gonna have 2 pKa's, pKa1 and pKa2. And the buffering region will be in the middle. Let's go third one, a triprotic. Triprotic is donating 3 hydrogen or proton atoms, pure molecules, and the curve will be one, two, three. So we're gonna have 3 equivalence points this time. One right here, one right here, and the third one right here. Point. To know like the buffering region, okay, so here's the definition. Where's the buffering region? Buffering region when the pH of a solution is about the same of the pKa of the solute. And we have another definition. We're gonna have some examples after that. Isoelectric point with the abbreviation is Pi, small p and capital I. When the molecule electrically neutral, when the molecule electrically neutral, And the formula for this is Pi for the neutral equal the pKa of the amino group plus pKa of the carboxylic group divided by 2. You have to memorize this formula. It's important. When we have this curve and has two pKa's, one right here and the other one is right here. So the first pKa equal to 3 and second pKa equal to 4. The isoprotic point gonna be right here. This is the Pi. So we need to find the Pi. As we know, the formula is Pi. We're gonna consider this is the whole graph is in neutral. Let me put that. It's neutral because later on we're gonna have an examples of acidic and basic conditions. So it's neutral. So the Pi neutral is the amino group plus the acidic group. The amino group we're gonna have the 3 plus 4 over 2 equals 7 over 2 equals 3.5. So this is the equivalence point. I have some notes for you guys. Notes. When pH of carboxylic acid equal the pH of the Pi, then it will be neutral. Second one, amino acid with acidic side chain have Pi value less than 6. And the amino acids with the basic sites chains have pi value high above 6. Let's write down the formulas for the pi. So the pi acidic amino acid equal pKa of the R group plus pKa of carboxylic group divided by 2. And the pi, of the basic amino acids equal pKa of the amino group NH3 positive plus pKa of R group divided by 2. You guys really have to know all these three formulas: the acidic amino acids and the basic, and the first one is the neutral in the previous slide. Uh, and be caution with the amino acids. You need to know all the names with the and how to draw the molecule. Because each of them will specify the R group from the amino group from the carboxylic groups, and that's how you're gonna distinguish between the pKa's for each of these, because in the problems they're gonna give you 3 different pKa's or 2 different pKa's, and each of these pKa's represent one of the functional groups. So you have to know like how to draw the molecules and memorize the names like on hearts. Let's do some examples. First one. Let's say we have aspartic acid. Aspartic acid has three different pKa's. pKa 1 is 1.88. pKa 2 is 3.65. pKa 3 equal 9.60. By the way, all these values, it's specific values, like it cannot be different. So these values goes with the aspartic acids, and there's like a chart table shows all the values for all the 20 amino acids, different amino acids. So aspartic acid, you have to draw the molecule first. As we know, it has carboxyl group and has amino group, and a plus it has the R group, which is also carboxylic acids. So this is R group, and this is carboxylic group, and this is the amino group. Let's do different colors so you can distinguish. This is a group, and this is carboxyl group. So we know the pKa for the carboxylic acid is always about 2, and we know the amino group has the pKa about between 9 to 12. So the R group is this one. We go back to the formula, which is aspartic acids. It's considered like negatively charged acidic side chain. Negatively charged. So this is negatively charged. That means it's acidic. We go back to the formula. It says here the acidic is the pKa of R group plus the pKa of carboxylic group. So the pKa Pi equal R group. Which one is the R group? We said this is about 2, so this one is the carboxylic, and the amino, it's close to between 9 to 12, so we have this one is the amino group. So the formula says R group, so this mean is the R group. This value means it's the R group. So we're gonna put 3.65 plus the 1.88 divided by 2 equal, after you do the calculation, you're gonna get 2.765, which is, we're gonna end up with this 6x. It's 2.77. Let's have another example. Another one is arginine has 3 pKa's, pKa1 equal to 2.17, pKa2 equal to 9.04, pKa3 equal to 12.48. As I said before, all these values will be given to you. The carboxylic group and the amino group. Let's draw the R group. The R group is like has a long carbon chain. So this is the R group. And this is the amino group. This is the carboxylic group. As we know, like this one is close to the amino group because the amino group is between 9 to 12. So this one is supposed to be the amino group. And we say the carboxylic group is about 2. So this one is the carboxylic group, and this one is above the amino group. It's 12.48. That means this is the R group. So let's put down the formula. The PI equal for the basic one, basic amino acids, equal to the pKa of the amino group, which is this one, 9.04, plus the pKa of the R group, 12.48, divided by 2, equal, it's 10.76. Do you guys got the idea of how to solve this type of problems? Let's have another problem. This one is a simple problem. It's not as complicated as these. Like we're gonna deal with only 2 pKa's. Let's say we have valine. The pKa's for the valine are pKa1 equal to 2.32, and the pKa2 equal to 9.62. Basically, this is the carboxylic group, and this one is the amino group. And this one is the carboxylic group. Sorry, I draw that. Sorry guys, this one is the carboxylic group because the pKa it's close to 2, and this one is the amino group. Let's draw the molecule. Valine it's one of the neutral products. So as we said, this one is positively charged side chain. The one before, positively charged base side chain. The valine is the neutral one. Valine is we have oh, this is not looking good. We have the carboxyl group and the amino group, and we have the R group, which is only 2 hydrogens. So this is the R group, and we have the amino and carboxyl group. So the pi for the neutral equal, as we remember, like the formula is the amino group plus the carboxylic group divided by 2. So we're gonna have now the amino group, the amino group plus the carboxyl group. So 9.62 plus 2.32 divided by 2 equal gonna be 5.97. Thank you guys for watching the video, and let me know in the comment below if you guys want me to upload more videos about this type of problems, and don't forget to subscribe and like.